Hey guys, this is Shalin. So today we are going to discuss about a very interesting problem called chef and Hamming distance from December long challenge. This is the problem statement. You're given an array A of n elements. What you need to do is you need to find an array B which is a permutation of A in such a way that the Hamming distance between A and B, the arrays A and B, is the maximum. This is the definition of Hamming distance. For unit Hamming distance basically is the number of indices I from 1 to n such that AI is not equal to BI. But there's a catch here. The catch is frequency of an element AI will be less than or equal to 2. The interesting part about this problem is that it's an ad hoc problem. So there can be various different solutions to this problem. I'll just explain the way I solved this problem intuitively. We are given 3 subtasks in this problem. The first subtask states that all the elements of the array A are unique. This makes the problem really simple. So let's say you're given an array A in which all the elements are unique. What you need to do is find an array B with the given conditions as mentioned before. What you can do is you can model the solution in this way. You can model this array A as a cyclic array. So let's say the elements of array A are A1, A2, A3, A4, A5. All of these elements, as you know, are unique. And you need to find B, which is a permutation of A. All you can do is you can take A5 in place of A1. A1 will move one place to the right, which is this. You got the array B. Now, just try to calculate the Hamming distance between the array A and B. As you can see, as all the elements are unique, the Hamming distance is 5 because there is no index I such that AI is equal to BI. Hence, this solves our subtask A. Let's try to solve the other 2 subtasks now. So now, basically, the frequency of your element can be 2 as well. So your array can have 2 different types of elements, one having frequency 1 and the other having frequency 2. So let's just divide our array A into 2 parts. One containing indices having elements with frequency 2 and one containing indices of elements having frequency 1. Now, as these elements occur twice, we need to store a list of pairs. So let's say I1, J1, I2, J2, and so on and so forth. And for 1, it's plain and simple, K1, K2, K3, so on and so forth. Now that we have this array divided in 2 parts, we can actually solve them independently. The right part, which is the list of indices of elements which occur only once in the array, can be solved using the same method as discussed in subtask 1. So let's say you have K1, K2, K3, K4, K5. This is the list of indices that we already discussed about. If you look closely, if you just move each element towards its right, then you have the solution for the right part of the problem. In order to solve this part of the problem where each element occurs twice, we can use a similar model as we used for solving the subtask 1. So you have I1, J1, I2, J2, I3, J3, I4, J4. All you need to do is think of this array in a cyclic fashion. And in order to arrive at the solution, you need to shift the corresponding first and second elements towards the right, one step towards the right. So what you can do is you can shift I1 here, you can shift J1 here, you can shift I2 here, you can shift J2 here. What this will do is, for example, let's say you have an array 1, 1, 1, 2, 1, 2. All you need to do is swap the first occurrence of 1 with the first occurrence of 2 and the second occurrence of 1 with the second occurrence of 2. If you use this technique, then, and if you think about it, then the Hamming distance between the given array A and the array B that you construct in this fashion will be maximum, because the elements at each index is different. Now that we have solved the two subparts of the problems independently, let's see if we are missing out an edge case here. What if the elements in the array do not change even after cyclically shifting them by 1? It happens when the size of the cycle is just 1. So the elements basically will come back to itself. This doesn't solve our problem here, so we need to find an alternate approach for this. We need to handle this case basically. If you think of it, there are just 3 cases wherein this thing can happen. So we have our pairs list and we have our singles list. Case 1 is when the size of the pairs list is 1 and the size of the singles list is n. The second case is when the size of the first list is n, the size of the second list is 1, and the third case comes when the size of both the lists are 1. So whenever the size of a list is 1, the cycle actually comes back to itself, which doesn't help us in any way. Now we need to figure out an alternate solution in order to handle these 3 cases. What happens when the size of the pairs list is just 1? It's simple enough. What we can do is, the elements that we have here, we can swap them with any 2 elements present in the singles list. What happens when the size of the singles list is 1? Very simple. We can just swap this single element with any of the first or second elements occurring in the pair size. What happens when both the lists have size 1? So in this case, you can just swap this element with any of the elements here. But this case is a special case wherein you won't have the Hamming distance of n if the size of the array is n. So I'll just give you an example of the case 3. Let's say you have an array containing 3 elements, 1, 1 and 2. Let's just run through our algorithm here. We have a pairs list which is 1, 2, which are the indices of element 1 because it occurs twice. The singles list contains just 1 element. So let's just run through our algorithm here. What happens if we swap? It just stays at the same place. Swap. It just stays at the same place. So we can just swap this 2 with any of these elements, and what we arrive at is 1, 2, 1. This gives us the Hamming distance of 2 because there is always going to be one index wherein they are going to coincide. As we saw, this was a very interesting problem because we solved it via an ad hoc approach, and ad hoc problems usually can have a lot of various different approaches. If you have any doubts, suggestions or feedback regarding this problem, paste your query in the comment below, and we are going to be out soon with the next problem.